I guess nowadays they call me a machine learning engineer. A few years ago I was a data scientist. Now I'm a machine learning engineer. I work at Hugging Face, and I'll be spending a bunch of time talking about Hugging Face. It's all open source tools like that. I like speaking at these meetups. I think I've been doing these for the last 5 or 6 years. I think I did one on Spark and image classification back 5 or 6 years ago. So it's a lot of fun for me. I appreciate you guys all taking the time to come down and kind of hear all this stuff today. The talk today is basically focused on if you're a data scientist or know a little bit about machine learning. The idea is I wanted to show you what's possible in this realm of kind of with new tools like transformers, for example. We'll talk a little bit about the text-to-speech and some of the other real-time speech tools. But all these tools, including, we'll touch on if you guys want to spend some time on things like the generative AI, stable diffusion, like all those cool tools that you see out there like that. And just, I want to make sure everybody knows like some of the big concepts there. And if you want to get started, like how would you get started playing around with this stuff? All right? Just ask questions as we go through this. I'll stop and pause. Feel free to kind of raise your hand or yell out something if you want as well. All right? Everybody with me? Okay. And as I go today, it's going to be a sampling. I'm going to just touch a lot of different topics. Other times I do like a tutorial, like in deep, like, hey, here's how you solve an NLP problem with transformers. But today I kind of want to just jump around and give you a taste of different stuff. From a data science point of view, I want to touch upon these different concepts around generative AI. We'll spend a little time on transfer learning, embeddings. We'll talk about like the next generation models, like multimodal, multitask, some of that stuff as well in the end as well. So just a preview. Start slow, but we'll get to some of the stuff as well. Now, for most data scientists now, if you're working on a problem, like let's say you have a house and you need to start understanding, right? Let's say you want to build a model to understand the value or the price of a house. So what do? Right? Like you have this like three-dimensional physical structure. What are you going to do? Typically, most people will be like, okay, well, we need to start understanding it. So we'll send somebody out to it, and they'll go out and they'll measure like, how many square feet the house is, or somebody will walk around and count the number of bathrooms in there. Right? These are what we call features or variables in machine learning, and we'll use that to start kind of collecting and gathering information to help us understand what this house is. And if you talk to a lot of data scientists, this is an important part of it. In fact, probably one of the biggest pieces as data scientists need to do is to talk to somebody that's in the business and figure out what are the relevant features. What are the features engineering that we should do? Because this is how we think about problems. We think about how we can kind of figure out the best way to pull that data and represent the problem that we have. Now, once we get this representation, then we're off to analyze it. Lots of data analysts out there spending a ton of time where we gather as much data as possible. Like there's data-centric AI. I like data-centric AI. The quality of data is very important. Often we, just in the quest to get as much data as possible, overlook that. But then we analyze data, and in a lot of business cases, that's useful. Right? That just gathering the problem, the historical record, and being able to look back and see what happens, it solves a lot of problems. We don't necessarily have to build a machine learning model for everything. But sometimes we want to look to the future, and that's when we build a machine learning model. Right? So this lines of model helps us figure out, like, for any new square footage, what the price is, right? So just kind of machine learning basics here for what we want to do. But the problem in doing this is it takes a lot of time to do this. Like if I built that model for Chicago houses, I need to go get some data prep, I need to label it, I need to engineer all those features, train that model to do that, and then I get predictions. But suppose, okay, I did it for Chicago, but now I want to do it for another city. Right? Like I have to redo that entire process, all those steps, over and over again for another city. And this is for data scientists just utterly exhausting. And if you talk to data science leaders, everybody's frustrated because the data scientists can't crank out stuff fast enough. Right? Data scientists are like, look, I spend 80% of my time preparing this data. Get me some clean data, get it organized, right? I'll be able to help it. But this is the reality of kind of most data science and organizations, that it's this way. And so the limits here, and I want to try to see if we can strike down a bunch of these limits as we go through there, is this, right? We're using these tabular features that somebody's going out and measuring to understand the world. We're restricted to thinking about predicting a number or a category for problems. A long life cycle to get to a prediction. And every task we do takes a new model. So I want to kind of attack all these a little bit as we go through this. All right. So let's talk about the changes, and I'm going to lightning speed through this because I'm just going to assume you know a little bit about machine learning, and if not, the history lesson's a great story, but for a longer lecture. We've made a lot of progress in the last 10 years. It's because we understand that having really large data sets is very powerful for both training and evaluating our models. Lots of new algorithms have come up, whether we talk about things like convolutional neural networks in the image space, whether it's transformers now, which are revolutionizing, or if you look at the generative space now, diffusion models are doing that. And then the third component has been GPUs, which have been a power horse for powering the training and the inference of a lot of these kind of new models. So these are the building blocks. I'm not going to spend a lot of time. If you want, I'll talk about it, but let's just take this as a given here. What we figured out over the last 5 or 10 years is when you build really large models, they're a lot more accurate. This happened in vision, it happened in NLP. The models are getting crazy big. So I started off as a data scientist in the insurance space, and there they build like these little linear models with like 7 variables. Right? Like you start with like 1,000, but like the final model that they finish, that like all of your insurance rates are based on, are just based on like 7 variables. So if you think about it, like it's like just a handful of parameters there that they're using to do this, but like these new models that we're going to talk about today literally have billions of parameters. So you can think about going from like a handful of switches to literally like rooms full of knobs and switches like everywhere. Like that's the mental difference between kind of the models that we're used to in the past and to the complexity to where we're at. But this complexity has a payoff, as we'll see. Things like our human language are very complex, and being able to understand the nuances of how we talk and accents and all that is a lot easier done when you have these much more complex models as we go through this. Okay, so let me talk about like applications of this. Like, how does this stuff work in real life? So my youngest kid is 7 years old, and 7 is about the exact same age as Alexa. So he's grown up in a world where the rest of us in the family, we use Alexa to turn on the music, to turn on the lights, to turn on the fan, and we're always yelling across the living room, hey, Alexa, do this, Alexa, do that. And so he's grown up in a world where we all talk to Alexa. For him, Alexa is really no different than talking to his friend, because he's even figured out that he can get Alexa to play toilet sounds and do fart sounds and all this kind of stuff with Alexa. But for him, like, and it was kind of bugging me a little bit the way he was talking to Alexa. So I actually made him say like, please and thank you, because like, for him, like, it's not any different than talking to a person in that way. And you know, the reason is because these systems, whether it's the Alexa, the Siri, the other call centers, they're all getting so good that we can almost talk to them in a natural way. I have one other story. So there was another company that put in one of these speech recognition systems. I'm afraid of this going on the internet, but they put it in a place for occupational injuries. And what they found is like they wanted the person to, instead of typing the form, they wanted them to tell them what the type of injury was. But they found like the person was just kept talking and talking and talking. They had these huge transcripts of like really personal details because people were so comfortable talking to the machine rather than having to write the injury. So I think we've all gotten quite used to this. But okay, I'm getting away from that. We all get the point. It's easy to talk to stuff nowadays. The other piece of this is searching. So if I watch my daughter and how she does searches nowadays, she'll type a query like this into Google. And for somebody who's grown up from the early internet. Like I remember like Alta Vista, these early tool search engines. Like seeing a query like this, it just kills me. It just breaks me. Like, why would you say things like eat better? Like, you have to be a clear thinker by it. Like, you have to think about what it is. It's not eat better, it's because, you know, you're trying to gain muscle or you're trying to lose weight. Like, there's some objective that you have in mind that should be part of your query, right? You can't use slang things like Xmas, like you're gonna arbitrarily, like, limit the size of your query by doing that. Right? Like, these are the things, like, for us that have grown up searching, like, we think about, you know, when we put together a search query. But the reality is like, and we know this, like, you type this in, you'll still get a really good query now. Like, the search engines have figured out how to talk and how to understand this. And the way it works is, it's simply kind of a semantic search where it translates all the words that we type into the search engine, puts those into numbers, takes those numbers, groups them together, figures out relative concepts together. So you can see we have kind of different concepts here. This is like traditional word vector stuff. And so even though I don't say eat better, right, it figures out that eat better and healthy are related to each other. And this is the backbone nowadays of things like semantic search. Google a couple years ago switched and made a big deal of how it started to use BERT for semantic search in its search engine. Meta, Spotify, all the stores, like everybody uses this stuff for doing search. And beyond that, you'll see that that same technology is what powers a question answer system. If you go and you want to try to ask something like, hey, what the question is, it's the same technology. Recommenders, right? Almost every enterprise has some type of recommendation system. Almost all those things nowadays, the modern ones, have these same types of embeddings that are inside. Okay, so that was quick. I got one more quick one and then we'll go to some code. But that's kind of embeddings, which are now kind of a normal thing within the machine learning world. So let's do one other here example. And I don't know how many of you have seen this. I think, you know, for me this is a ton of fun. This is GitHub Copilot. So you can use it for autocomplete of code. How many people here have seen it or played around with it? Oh, only half. Like, it's like if you have to code and stuff, like it's pretty cool. Like Amazon has its own, Replit built its own, like that. But you can like tell it in English, like, hey, I want a program like this, and it will generate the code for it. There was somebody took a version of this and tuned it for math, for all the calculus classes at MIT, like the first or 100 or 200 level math classes. And they would give it the math word problem, and the output of the model would be like basically the code for solving the problem, as well as the answer. And they found it was getting about an 80% rate for solving all the math problems like that. Like, it's amazing, like how good this stuff has kind of figured out how to do this. I mean, Google even had an internal study where they tested it, because they have a version that they're using in-house for code completion, and they found out that their developers improved their productivity about 6% by using it. Like, Google's a company that makes its money, like it doesn't sell things, right? It makes its money on software, right? Like improving the productivity of, you know, $240 billion company that way is pretty remarkable. And nowadays, if you look at their code base, and this was 6 months ago, 3% of their code is auto-completed. Right? So computers have generated a big part of that code base. So, I mean, this stuff of kind of the text generation stuff blows me away. I mean, right, we all use it in our phones, our email, we're all pretty much used to it. There's other businesses like Jasper. This is an example of like, you can ask it to write a paragraph and give it a topic, and it's gonna write the essay. Like, it's gonna totally change like how my 7-year-old, like when he goes to write like college essays or high school essays, like, it's going to be a totally different world because it's just so easy to have really good copywriting. And I work with companies that use this stuff in production. Jasper's a big company, but there's advertising companies, media companies, where their writers nowadays work hand in hand with these technologies. It's not the point where they kind of kick the humans out of the room, but it's where the humans and the computers are working together and creating a lot of content like this. Right? The text image, hopefully you all haven't been living in a cave and you've seen this stuff. This is just amazing of how you can do this. It's literally like changing week by week. It's a really fun space. There's zero-shot object detection. This was another fun one where you can give it a picture and then ask it, are these objects in it? And the model hasn't seen the objects before, but in this case you'll see like you can type in things like peach and champagne bottle, and it's identifying where in the picture it is. It's just like cool, super cool things. And as I'll show you, it's like just a couple lines of code to be able to do it. Okay, so this is the other big thing, and I think this is a really big shift for data scientists who, when I have a conversation with my business customers, usually we're talking about looking back historically, or if it's a machine learning problem, I try to get them like, give me a number to predict, give me a category to predict, so I can build a machine learning model on that. But like with the ability to do generative solutions for things, it really changes that conversation of how AI can be helpful within an organization. Okay. So this is so much faster, you get this. Let's take a few minutes. I want to show you guys how we can play around with some of these tools and get a sense of this. I'm going to shoot for finishing around 8:30. Is that cool? I can go later. I can talk about it, but I want to make sure you guys get out of here. So let me show you guys how you can use these technologies. So for those of you who aren't familiar with Hugging Face, we have some easy web pages, and I'm going to go to some of them to get you started. So if you're on a laptop, you can play along with me like this. So, I'm going to have to blow up this page here. Okay. Does that look okay? Can you guys read that in the back and stuff? Can you see it? Okay. So on the Hugging Face website, you got to use this little weird thing over here. There's something called tasks. And what we've done is we've went through a lot of the common machine learning tasks where there's pre-trained models already for these. And whether we have here, we have computer vision. If we scroll down, we have natural language processing tasks, audio tasks, and I'll dig into all of these here. And then we also have tabular, multimodal. So this is an easy page that if you're a data scientist, and that's what Hugging Face is all about. It's about helping the software developers, the software engineers, the people that build this stuff, make it very easy to use all these machine learning and AI tools. So if you're in that category, so let's do the automatic speech recognition one first. Okay. We talked about automatic speech recognition earlier, but like you're like, what is it? How does that work? Like if I want to grab some automatic speech recognition and bring that into my application, like what would I do? And you'll see this task page has a very simple, like, hey, what's the input for this model? What's the output? There's like little video snippets that explain kind of what it is, use cases of them. But over here on the right, we even have like little widgets. So you can see this is a demo using this particular model. And what I can do is I can even just try it right here. So I can see how this is working. Let's see if it does anything. I can hit stop, and then I can compute here. And you can see, like, it does that kind of right there, real time in the browser. But the nice thing is like, you can go and check this out and play it with it. And then if you're like, oh, I want to dig in a little bit deeper into this, like, tell me about this model. I can open up a page here. I clicked on that tab. And here's the model page for that. So like all this information is freely available to you. You can see this is a pretty popular one, 500,000 downloads, but links to the paper, right? The model, hey, I want to use this. Well, here's a code snippet that you can grab if you want to use that model and literally like cut and paste that into your Python notebook, and you're off and running to do that. Like we talked about Whisper earlier, like hey, if you wanted to, like hey, I want to check out Whisper, you go here, I'm going to just click on one of these here. Here's OpenAI's Whisper model. I can read about it, I can try it right here in the browser. If I want to go download it, you can see here there's files, I can go grab it. So the idea here is for the people that are kind of doing this stuff, we're just going to lower that learning curve, make it very easy for you to get started. I'll do one other task. Anybody, what other tasks are people interested in? There's like a ton of tasks on that page. Sorry, it's not yourself. Computer vision, NLP, help me pick out another task here to look at. There's a bunch of these computer visions, right, object detection tool. NLP, summarizations, push and answer,
That's the generative stuff.
multimodal, stuff like that. So the generative stuff we have, it's the diffusers library. We have some spaces, I can show you like that, but in terms of tasks, I don't think we really have anything in the tasks yet. The closest one, I mean, image to text, I don't know if that's, let's see, I don't think, the text to image, I think they're still filling out. Some of these are building. Yeah, this is a placeholder, they don't have, we have like a documentation thing where it's an open source. We have like contributors from everywhere contributing documents.
You had video classification.
Mm-hmm.
I think it was a little tough.
Yeah, like again, like some of these with the contribute, like they're doing a push right now to get this. So in like about 2 weeks, this stuff will be full. Or if you have people that can do it, here I'll just go to object detection in the meantime.
Marcia's a question.
Excuse me, I have one
Yes.
question. For most of these pre-trained models, I guess it's supervised learning, right?
Yes.
How much effort did you put to pre-train these models?
Well, so it's a good question. So these models here were all donated by the community. So it's OpenAI, it's Facebook, it's individual researchers that have uploaded and shared their models. Now, Hugging Face will kind of vet the models, put them out there like that. But for most of these are existing models that are kind of pre-trained for these. And I'll talk a little bit about how we fine-tune them here in a few minutes, like for a particular task, like that. So, yeah. So this is just like out of the box. If you wanted a model like this, you can see here, like this DTR model. We can take a look and you can see out of the box, it can solve these different types of problems. But yeah, in a few minutes we'll talk about if your problem is a little bit different than these, how you would do that. But again, right, like there's kind of a quick link there to get through it, right? You can watch Nate talk about it. And then if you want to run it, right, literally like 2 lines of code to be able to do it. Okay, good. I'm going to show more code here in a second. I think I got 2 more slides to show. So that's the task page. I like to get all data scientists just looking at that, just so you know what are the easy to do tasks in machine learning that are just simply a couple lines of code that we have existing pre-trained models for. Now, if you want to start coding these, this is where Hugging Face has the Transformers library. It's one of the most popular libraries that are out there in the open source. It's just tremendously grown. It's crazy. I think it's something like 70,000 stars on GitHub, which shows that it's much larger than just data scientists. It's also lots of kind of software engineer types that have figured out, hey, for a couple lines of code, I can build a sentiment analyzer and put that into an application as well. So let's take a look at some of the code just to give you guys an idea of how you would do some of this as well. My time is fleeting fast here. So I have the notebook here, bit.ly raj.ai. And take a look. I'm not going to spend a lot of time in the notebook today simply because I want to show you and get to other cool concepts. But this stuff is really very simple to do. For example here, sentiment analysis. Something that before you used to take me 50, 100 lines of like code in R or Python to like build a sentiment analysis model. Here you can say, like, let's say I'm going to change this to sad. Like I have 2 lines of code to set up that pipeline. I just tell it I want a sentiment analysis pipeline. With the Transformers library, it's going to select a default model to use and then give me the result. So I don't have to worry about kind of all the other steps there, the tokenization, cleaning, all that stuff is hidden away for you. Now, if you want to get into this, this is where it's open source library. There's other ways to kind of dig into the details of this, but this gives you a very kind of low code way of doing it. Like the text generation stuff. So, and this is like every time I run it, it's a little bit different. So let's see, on Once Upon a Time, This planet and its inhabitants did not exist as we know. But this is where, if you wanted to kind of automatically tell you a story, let's see what's going to happen here.
So you can specify the underlying model from the API, or?
Yes, you can. So in this case, I just went with the default model for the pipelines, but you can always, and if you go through this notebook later, if you want to use a different model, so let's say I want to use the object detection pipeline, but there's a different object detection model I want to use. Maybe I want to use a really large model for accurate. Maybe I want to use a really small one because I'm worried about inference speed. All you do is type in model equals, and then you put the location of that model.
Can you load your own models, or?
Yeah. So there's examples here for kind of image. Here's a multimodal one. Oh, so for this image one, here, let's do the image one and I'll show you. So this one, I'm taking this picture of this cat. So let me show you what it looks like. I call it fat cat. There it is. So that's what we're doing here. Okay? So memorize this scene here, because I'm going to need your help. We're going to go through, let's look at the notebook. So the first bit of model here is just an image classification model that just tries to see, what kind of image. And you'll see it gave it the lynx as the highest score, right? Behind that was cougar, snow leopard, Egyptian cat, and tiger cat. But here's the cool thing. Like, we can also put in other pipelines, like a visual question answer, where you can ask it any question. If you guys want to change this question, we can. We can ask it a question of the picture and it will give back an answer. So I asked it, is it cold? And you can see the answer, 99 is yes, but then the other answers were like no, snow, cold, and winter. Right? What other questions should I ask it about the picture? Anybody else have an idea?
Does a cat need to go on a diet?
I have no idea. Give it a second to do it. That's strong no. But this is that era of the multimodal where we're starting to ask questions to images. It's really cool. A lot more code in the notebook. I'm gonna leave out the notebook here for the next few minutes because I want to just hit a couple of other concepts in the slide as well. Any questions? Okay.
So with that model just now, what kind of question can you ask with the picture?
So it'll take in any text, any question in the world you can ask it. I mean, you might get nonsensical answers if you ask it crazy things, but it'll try to generate an answer for everything that you give it, based on what's in the picture. It's using that as an input. And so, you know what, before I jump into that, I should point out, if you're interested in any of this stuff, the starting point is that tasks page, but if you just want to explore, all the cool things you can do, there's this spaces area, and if you were around during, the DALL-E Mini era, right, you were going to Hugging Face's spaces to do that, but this is where literally, every research paper now is putting up a space around that. Every major development in ML has a web demo that's on this site. And a lot of times the code is available there for free. Try that out. If you want to do that, you were editing audio, but here's a cool demo, for example, of editing video, where you take a transcription of a video, and then if you cut out some of the text, it'll actually cut out that part and make a video without that part of it, like that, literally editing that video for you. So lots of cool stuff like that, will totally blow your mind. Go play around with that stuff as well. Okay, let's see. So this is where we had the other question is right now when you work with these things, if you use BERT, which is a widely available model, Well, BERT is trained on Wikipedia and a books corpus, which is great if you're like just analyzing everyday tweets, but like if I have a financial customer and they care about markets, right? The word market can mean going to the store, but if you're a financial customer, it has a very different meaning for them. And so what we see in many domains is we start with these pre-trained models, but we might want to build our own. If you're in finance, you might build a financial one, right? Healthcare customers, for example, medical records, lots of weird abbreviations, language like that, build their own. Patents. Source code, we talked about the code generation earlier. Right? That needs a different language model than one that's trained on Wikipedia, like that. But it takes an enormous amount of money to build these models. So the other thing that kind of, you stick enough graduate students in a room, and what we figured out was we can take one of these large language models, but just tweak a little bit of the model and retrain a little bit of it, and that's called transfer learning, and brings over a lot of that knowledge. And so I remember talking about transfer learning years ago when I was doing an image classification meetup like that. So hopefully most data scientists in the world know this, but this is how we take advantage of those large models for other specific tasks that we talked about that might not have been in the original, within the original purview of the model. Like that. So here's a financial one that I did. If you go back to that Hugging Face hub that I showed you, and we take a look at the kind of the models here on this, this is where the vast majority of models, you can see there's 83,000 models, are made not because they're pre-trained on huge corpuses, but that they're fine-tuned for different tasks. And so this is where, like, if I type in food, you can see there's lots of fine-tuned models where somebody's taken an image classifier, but I've given it a selection of, hey, these are the foods that I want to be classified as, and then tune the model towards them. Everyone with me? I'm going faster. Okay. So, I want to hit the last thing I want to, and again, I'm going to skip the risks, caveats. Watch out, models can be bad. Oh, I need to go to slideshow. That's what I'm saying. So I think the last thing is if we're like thinking about the future of what's going on and what's next with these models, is just this fusion that we have. So we see this with things like Stable Diffusion and generative models of fusing the world of text and images together and being able to work with both within one model. So for example, right, being able to give it some text and then being able to come up with the image is the simplest example of this. And people are like, well, okay, that's nice, like, creative stuff like that, but like, how is that going to help my like business? What is that going to actually do in that? But this is an example of that document visual question answering applied to documents within an enterprise. So in this case, you can ask it, and there's demos out there, like what is the invoice number? And all you feed it is just the PDF image. You don't OCR it, none of that, just the image information itself. But if you give it the image information itself and the question, it can figure out that what the invoice number is from this. Like I even did play around with it the other day, so this is another one of these spaces that you can go to, and we even did like, hey, who signed this? And it actually came up with John Smith, like I had no idea, but it actually figured out, it said, hey, John Smith was the person who signed this invoice. So like the stuff of merging this stuff is gonna like, has practical uses like that. So here's some other examples of this, like visual question answering, where you can take these different types of documents, ask it these questions, and return back the answers. And there's different types of setups, sometimes where you have generative setups where you might have different answers every time, sometimes you have real definitive ones where you want to just extract and not have that variation depending on your use case, like that. So, but in this case, in the document AI case, this is a multimodal model that merges the textual information with the image information as well. And so this document AI.
How sensitive is it to spatial relationships between, for instance, the invoice label being on the left and the invoice number being on the right?
So it depends on if you train it. If it's a strong feature for the position of it, Like if it always knows, for example, like, let's go with page number. Like it always figures out that the little number at the bottom is the page number, it's always at the bottom. Like, and your training data has that, like it's gonna learn that representation and use that.
So you have to include different type of pretties in order for it to be space invariant.
Yeah, so they're pre-trained on like some random corpuses, but yes, if your documents are very different or have a different distribution shift, you'd want to kind of train with that piece there. Yeah. Okay. So this is the other big trend I see is a lot of times we focus on kind of tabular data in enterprises that gets out there, but I've seen a real shift now where we have this tabular data, but we can now use these multimodal models that can take traditional tabular data like my user demographics, but also take tabular data that's maybe like session information, so information about a particular call, and put that into a tabular form and combine both of those in one model. But now we can also like bring in the big text description, create an embedding for that, and bring that in the model. Use the vision, if there's a text or if it's a car, bring the picture of the car in as well as part of the representation. Right? The audio of the call, maybe the actual audio itself, besides the text transcript. We can create these embedding representations and bring that in to a model. Another shift I'm seeing is multitask, and this is kind of Karpathy. This was last year talking in Tesla about how they had different models for these different tasks. Moving objects, static objects, signs, and traffic lights. But what they were able to do was take advantage of transformers, take advantage of models, and instead of having 4 different models, put this all into one model that then supported these different tasks. And like everything in engineering, it has its trade-offs, but in some ways for him, this simplified a lot of things by having everything in one model. So this is another movement that I'm seeing is where, especially places that have 10, 50, like 100 models out there. Like these guys, you can go check out podcasts like Sean Taylor Band, are talking about like how in the future they would like to move towards a world where they have fewer models that support things like multimodal inputs, that support multitask outputs. And the cool thing is in the beginning of this is what we're seeing in these super large language models. So these are the things that have like 50 billion parameters, like the GPT things that you see that are talked about. One of the things they have is they're able to represent so much information within this large language model that something that's called in-context learning happens. So the learning that we've talked about all the time has been the supervised paradigm, where we handed a bunch of training examples, like lots and lots of training examples for it to learn. But the latest generation of these models has so much information inside it, like we don't have to give it additional training data for it to learn. Like it's already learned and learned everything about the world within its model. What we need to do is just talk to it and have a conversation. And if we do, we can pull that out. So, for example, like a sentiment model. In the past, if you wanted to do a movie review model, you got lots of examples of sentiment that you would train the model on. But with these large language models, what we're able to do is this few-shot learning, which is really cool, where we just tell it like, hey, if you see, I want you to give you a review, this is the type of output I'm looking for you. Like, is this negative or positive? All you have to do is just hand it a couple of examples of that, and then the model will be like, oh, I get what you're talking about, and then we'll give you predictions in that way. And this is something that's called few-shot learning, and it's because there's so much information within these models. And it's a totally different way of like doing machine learning with this. And this is also going to be like another thing that's going to change a lot of paradigms. All right. I took like a 45-minute, like a 90-minute talk and compressed it to 45 minutes. I'm going to lose everybody in this. Okay. So that was, here's my final slide. So that's what I wanted to give you is like, hey, lots of different use cases we could think about, semantic search, document AI, I talked about some of these other ones. A lot of different use cases, lots of different ways to think about how we do machine learning from the traditional kind of way of, the old way of, right, like labeling, feature engineering, training, whether using pre-trained models, whether using transfer learning and doing the fine-tuning, or taking advantage of these new kind of next generation large language models to do this in context. All the tools like this, a lot of the stuff is available as open source, so you can get out there, get your hands dirty right away with this. Let me get my last slide. Feel free to reach out to me on LinkedIn. I also have this Registics handle, and I do TikToks as well. So if you like bite-sized versions of your data science and not like all 45 minutes, I also have an Instagram. Like I just started copying them on Instagram because some people would refuse to get TikTok, and I was like, okay, I'll put them on Instagram for you as well. All right, thanks everybody.
It's more of a philosophical question than
Yeah.
anything else, but one of the problems with these multi-models today is catastrophic forgetfulness. If you have a multi-model, then it comes at a price, and the price is usually accuracy in all the domains. Given where we are today with respect to all the accidents that have happened in self-driving cars, is it a good idea to keep pushing this into something where people would lose their lives versus saying, okay, maybe we can improve on one model and make sure that it doesn't cause any loss of life before trying these other technologies?
Yeah, and so what I tried to do today was give a lot of samplings of lots of things that are out there and lots of cool things. Now, there's lots of attributes like in engineering that we care about when we're building these things, like for example, like robustness is an attribute that can often comes into play in these things. Like inference time comes into play, right? There's a very much between a real time in a car versus like what I can do in a research lab with one of these language models. So there's a whole host of like trade-offs on all this stuff. Like I'm an advocate of doing the research and trying this, but when it comes to applying them in a specific domain, especially sensitive domains, whether it's things like human safety on the line with like a car, but I skipped over all the slides and my people at work will kill me if they saw this, but like there's a whole set of like concerns about bias with all these models too, and representation like that, and are they carrying those issues forward with these? So like, I handed out a bunch of toys, but like the toys have like, are dangerous toys, so yeah, they have to be used properly.
Yeah,
It's
with the
it's in the waiver before you download it.
Licensing, right?
Responsibility.
We've added responsible licenses. Actually, I mean, it is true. Like, if you look at one of the things Hugging Face has done is they put together a model called Bloom, which, if you're familiar, OpenAI has GPT-3, which is like the big language model it has. But like, good luck getting to understand and getting to use it. Like, it's there. If you give them money and use their API, you can use it. But if you want to download the entire weights of the model itself because you want to use it internally, you're not allowed to. If you're an academic researcher and you want to understand these models, like, you're totally out of luck. And so that's why Hugging Face over the last summer built Bloom, which is 160, I don't know, whatever, it's a huge number, it's a billion parameter model, but made it openly available to the entire research community, as well as the corporate community if you want to use it, where all those weights are available and you can download and use them. But it came with a license called RAIL, which is responsibility in AI, because we wanted to ensure and promote this. It's a great question. So OpenAI is going to release GPT-4 probably in the next couple months or whatever, and you'll see some insane demos on that stuff too. Like all this stuff. Like if you see like the spreadsheet demos and stuff, like where you type in stuff, like it's such cool stuff.
This is very interesting. I mean, there's GPT-3 and GPT-4, and there's trillion parameter models available right now, large language models. And part of the reason bias that Rajiv talked about is inherent in these models, and the designers of the models know that there's bias, but they've made a conscious decision not to go back and retrain it because the cost associated with retraining is so massive that they just don't do it. So so it's interesting. I mean, last year, for those of you that attended NeurIPS, Timnit Gebru gave a talk. She was the researcher that was fired from Google. last year, if you remember. And her point was that we are creating all these stochastic parrots, is what she called the models. But these come at a price because what these stochastic parrots learn is essentially languages like English or Dutch or French, which takes so much energy to train, and what these models disproportionately affect are the folks living in the equator, because these data centers, take up a lot of energy, they contribute to greenhouse, and then the effect that is being faced by these is on a proportion of the population that doesn't even benefit from these models. So there is lots of ethical issues to think about in this area as well.
The energy consumption of all this stuff is just insane, right? With GPUs.